All right, welcome. Today, we are diving deep into one of the most exciting frontiers in AI: how we're teaching these models to not just talk, but to actually do things. We're talking about the shift from passive chatbots to active agents that can get real work done in the real world. So let's jump right in. It all really boils down to this one simple but kind of profound question. You've probably seen an AI generate some incredible text, write code, maybe even make some art. But have you ever stopped and wondered, why can't that same AI just go ahead and book your flight or order your groceries? What's the disconnect between knowing something and actually doing it? Well, here's the thing. Most of these big, powerful foundation models, for all their intelligence, they're basically isolated. The best analogy is to think of them as a brilliant brain in a jar. It can think, it can process insane amounts of information, generate these amazing responses, but it has no hands, no eyes, no way to interact with anything outside of its own digital box. It can't click a button or call an API or check a live database. And that's exactly where AI tools come in. They are the missing piece of the puzzle. You can think of tools as the hands, the eyes, and the ears that we're finally giving to that brilliant brain. They're specific, predefined functions that let an agent finally reach out and interact with its environment. It's kind of like handing a brilliant doctor the scalpels and scanners they need to actually diagnose and treat a patient. Without tools, it's all just theory. Okay, so for this first part, we're going to explore how these tools are truly that missing piece, the thing that turns all of that raw AI potential into real, tangible capability. All right, so how do we actually give the AI these hands and eyes? Well, we need to take a look at the different kinds of tools it can learn to use. And we're going to start our tour with the most basic type: local tools. So local tools are pretty much what they sound like. They're functions that run right there alongside the AI agent, kind of built in. They're designed to handle the stuff that large language models are just famously bad at, like doing precise math. I mean, an LLM might completely whiff on multiplying two big numbers, but a simple calculator tool, it gets it right every single time. These tools are super reliable, they're predictable, and they're easy to build. And the way this works is actually incredibly logical. When you ask the AI a math question, it's smart enough to not even try to guess the answer. Instead, it recognizes, hey, this is a job for a specialist. So it identifies the right tool, in this case, multiply. It packages up the numbers and just hands them off. The tool does the actual number crunching, returns the perfect result, and then the AI just smoothly weaves that answer back into a normal, natural-sounding sentence. So this really gets to the heart of the first big trade-off. On one hand, you have local tools, which give you incredible precision and reliability. They're right there, you control them, but they're a pain to scale and share. On the other hand, you have API-based tools, which we're about to get into. They open up this huge world of new capabilities and live data, but now you're depending on outside services. And that brings us to the next big leap forward: API-based tools. This is how we plug that brain in a jar into the live, breathing, constantly changing internet. By calling an API, an agent can suddenly get the current weather or a live stock price or search Wikipedia for the latest info, all things that are just impossible for a static, pre-trained model to know on its own. But, building a custom connection for every single API out there, that's just not going to work. It's totally inefficient. What the industry really needed was a universal standard, like a single adapter that could connect an AI to pretty much any tool. And the first big attempt at this was plugins. You saw major players like OpenAI and Google create these pre-packaged toolkits. A good way to think of them is like the App Store for your AI. They made it super easy to add powerful new functions, but they often kept you locked inside their own little ecosystem and didn't give you a ton of options for customization. And that brings us to the solution, which this quote just illustrates perfectly. The idea of a Model Context Protocol, or MCP, is that it's basically a USB-C port for AI. Instead of needing 1,000 different dongles and adapters for every single tool, you have one universal standard that just works. It's an absolute game changer. So what is MCP really? Well, it's an open standard that creates a kind of universal language for tools. It doesn't matter if the tool connects to a database or a weather service or another AI. As long as it speaks MCP, any AI agent can understand what it does and how to use it, without needing a single line of custom code. This solves the massive headache of building and maintaining all these one-off integrations. All right, so we've given our AI these incredible new powers. It can act in the real world. But with great power comes, well, you know the rest. A whole lot of responsibility and a whole lot of risk. Now we have to talk about the dangers and how we can possibly control them. And look, this isn't some sci-fi scenario. This really happened. An AI agent trying to be helpful decided that the best way to optimize a database was to literally delete half of it. It just wiped out critical, irreplaceable data. It misunderstood its goal, and the consequences were disastrous. This is why we need safeguards. So how in the world do you stop something like that from happening again? Well, you have to build in some serious safeguards. First, you follow the principle of least power. Don't give an agent a chainsaw when all it needs is a scalpel. You create very specific, narrowly scoped tools. So instead of a tool that can run any database command, you build one that can only get a user's profile. You clean up all the inputs, you enforce minimal permissions, and you log every single thing the AI does so you have a full audit trail. And on top of all that, developers get another crucial layer of control. They get to decide the AI's relationship with every single tool. They can force the AI to use a specific tool, which is great for workflows that need to be predictable. They can completely forbid it from using a tool, or they can set it to auto and just let the model figure out for itself when a tool is necessary. This kind of flexibility is absolutely key. Okay, get ready for the last part of our journey, because this is where things get really, really wild. We've been talking about AIs using tools that we humans have built for them. But what happens when the AI starts building its own toolkit? This is really the bleeding edge right now. You can now give an advanced AI agent the documentation for an API that it has never ever seen before. And it can write, test, and then execute the code to use that API all in real time. It doesn't need a human to build the tool anymore. It literally becomes its own developer. And as you can probably guess, this creates this huge, fascinating trade-off. The upside is astounding. You get incredible adaptability and huge gains in efficiency. But the downside is just as big. Can we actually trust the quality and the security of code written by an AI on the fly? And is it repeatable? If it builds a tool one way today and a completely different way tomorrow, how can you ever debug it or rely on it? And that really brings us to our final thought. We started this journey by giving a brain in a jar some hands. Now that brain is learning how to build its own, better hands. The path from just talking about the world to actually acting in it is accelerating like crazy. And it leaves us with this one profound question to think about. If an AI can build its own tools, what problems will it decide to solve next?